Noor, is it your first class with me? Noor, you can use chat room or you can even No, sir. Noor, you're from Bahrain, no? We have done this before. You were in that course on vectors. Okay. Minutes. Walaikum Salam, Abdullah. Rashad, are you the same Rashad of class 11th or?
Yes, sir. Yes, sir. Same, Rashad.
Okay, so we'll start with the first unit of NCRT. The first unit is physical world and measurement. And the very first unit, physical world and measurement. Physical world and measurement.
Sir, is it the first chapter?
Unit number 1 and measurement. This unit number 1 will include two chapters. This will include chapter number 1 and chapter number 3 of NCRT. Chapter number 1, it will include NCRT, chapter number 2. This chapter number 1 and chapter number 2. We divide this first unit into 3 chapters. The first one is Introduction to Physics. The first one is Introduction to Physics. This Introduction to Physics is basically chapter number 1 of NCRT. It's basically NCRT chapter number 1. Or it's a very introductory chapter. In this, there's nothing in this chapter that I can teach you. There's only the name of the scientist and the theory. So I'm not considering chapter number 1 here. The next is dimensional analysis. If you want, I can teach this at the end, but there's no point in taking this chapter. There's just the name of the scientist and name of the theories. There's nothing which a teacher can help you with. The next is dimensional analysis. The next is error analysis. And the fourth one is measurement of length, mass, and time. Fourth is measurement of length, mass, and time. So these are the 4 chapters. So these chapter number 2 to 3 are basically included in chapter number 2 of NCRT. So I'm not starting with introduction to physics. I'm rather starting with dimensional analysis. So start with dimensional analysis. This dimensional analysis starts with the concept of physical quantity. This starts with the physical quantity. The concept of physical quantity. So physical quantity simply means quantities that can be measured. Whatever the quantity you can measure is a physical quantity. Like you can measure mass, mass is a physical quantity. You can measure time, time is a physical quantity. You can measure speed, it's a physical quantity. Whatever the quantity which can be measured is like a physical quantity. So physical quantity simply means quantities that can be measured. Whatever that you can measure is a physical quantity. So physical quantity simply means quantities that can be measured. Quantities that can be measured are known as physical quantity. Next, we can divide, for example, like say speed is a physical quantity, volume is a physical quantity, energy is a physical quantity. Can I say that emotions are physical quantity?
No, sir.
No,
sir.
sir.
No, sir.
No, sir.
Can't measure emotions. So emotions cannot be considered as a physical quantity. Rather, we can consider force as a physical quantity. So quantities that can be physical quantities. So these are some examples of physical quantities: speed, volume, energy, force. So just note it down. Let me know if you have any doubts in it. Fatma, I just have started unit number 1 of NCRT.
Yes, sir, I know.
Fatima Sharif, you have done vectors with me, right? You were there in those lectures of vectors, Fatima Sharif.
Yes, sir.
So what's your school name, Fatima? It was
Ibn al-Haytham, Islamic.
so. Shall I rub it?
Yes, sir.
Sir, just a moment,
Yes.
just a moment. Okay, sir.
Next, we can divide these physical quantities into 2 categories. We can further divide them as these are physical quantities. You can further divide your physical quantities as scalar quantities, not scalars, as fundamental, as fundamental and derived. So you can further divide your physical quantities as fundamental physical quantities and derived physical quantities. Fundamental physical quantities are those quantities, like you can understand this fundamental and derived from a language. Say if we talk about English. In every language, there are some letters. Like in English, there are 26 letters A to Z. Each and every letter is fundamental in itself. It's fundamental in the sense if I ask you to make B, Can you combine all letters and derive B, or is it fundamental? Is it possible to derive a letter?
Fundamental.
No, sir.
You cannot derive all letters, right? If you combine all letters from A to Z, even then a letter B. So each and every letter is unique in itself. Each and every letter is fundamental in itself. But after this letter, in any language you come across any word like this, physics is a fundamental letter or it can be derived.
Derived.
So all
Right.
words are actually derived from these letters. So just like language, in language you have two basic structures, some letters which are fundamental. There are words, sentences which are actually derived from these letters. Just like any language, in physics we consider certain quantities as fundamental. These fundamental quantities are just letters, they are fixed quantities. You can't derive one quantity from another. These fundamental quantities are just like letters in any language. Then there are quantities which are known as derived quantities. These derived quantities are actually derived from these letters. In the same way as these words are derived from these letters. So we can derive fundamental quantities. Fundamental quantities. So fundamental quantities simply means quantities. Just like letters, if I ask you to derive letters, then letters simply means letters are alphabets or something which cannot be expressed in terms of other letters. So the same way, fundamental quantities means quantities which cannot be expressed, in terms of other physical quantities. So fundamental quantities are simply quantities which cannot be expressed of other physical quantities. In SI system, we have 7
So what have you written there? In terms of other?
physical quantities. In terms of other physical quantities. Other physical quantities. In SI system, we have 7 fundamental physical quantities. Fundamental physical quantities. So I assume that you people are aware of SI and CGS unit. So Fazil, what is the SI?
Yes, sir.
What is the SI unit of mass? Fazil, Shabazz.
kg.
Kilogram.
Yes, SI unit of mass is kilogram. What about the CGS unit?
Gram.
SI unit of length?
Yeah,
Meter.
Meter. CGS?
Centimeter.
Yes, sir.
Centimeter. SI unit of force?
Newton.
Then what about CGS of force?
Kg Newton.
No. CGS unit of force?
Dyne.
Dyne, right. CGS unit is dyne. CGS unit of force is dyne.
Sir, what is CGS?
CGS means centimeter, gram, seconds. Basically, there are many systems for measuring units. The two major one are SI, International System of Unit, and another one is CGS, which is centimeter, gram, seconds. So when you use CGS, you measure mass in gram, you measure your length in centimeter, and time is seconds. But while you are using SI, you consider your mass in kilogram, you consider your length in meter, and time in seconds. So these are two major systems for measuring units.
Okay, sir.
We concentrate only on SI system. So in SI system, you have 7 fundamental physical quantities. If you change system, then number and the nature of physical quantity can change. But right now we have to concentrate only on SI system. In SI system, we have 7 physical quantities. Just note it down and let me know when you have written.
Done, sir.
Done, sir.
Done, sir.
Done, sir.
Done, sir.
Okay. So I'm rubbing it. Fine. Okay, the next is, let's make list of all fundamental physical quantities. So this first column is for serial number. Second is for physical quantity. Then this is SI unit. So the first quantity is mass. We represent mass by capital M. The SI unit of mass is kg. After mass, the second quantity is length. We represent length by capital L. Its SI unit is meter. Third quantity is time. We represent time with capital T, and the SI unit of time is seconds. Then after time, the next is temperature. The next is temperature. We should represent temperature by capital T, but this capital T is already reserved for time. So instead of capital T, we either use theta or K. For temperature, we use these two notations, either theta or K. And the SI unit of temperature is Kelvin. We represent Kelvin by a capital K. So this notation K comes from Kelvin only. After temperature, the next quantity is electric current. The next is electric current. We can measure this electric current in ampere, it's capital A. The next quantity is luminous intensity. The next is luminous intensity. Now you are aware with first 5 quantities. You have used these first 5 quantities up to class 10. This luminous intensity is new quantity. Luminous intensity means intensity of light. It's simply the intensity of light. Yes. So if I give you a bulb of 100 watt and a bulb of 1000 watt. So the intensity of light from that 1000 watt bulb is more than this 100 watt. So that intensity of light is known as luminous intensity. That we measure in candela. The SI unit of luminous intensity is candela. Luminous intensity is simply the intensity of light. Then the next is amount of substance. The next is amount of substance. Yes.
Mole.
Amount of substance we measure in mole. So 1 mole simply means 1 mole is 6.023 into 10 raised to the power 23. If I say 1 mole, say 1 mole pen, 1 mole pen means this much of pen. If I'm saying say 1 mole atom means 6.023 into 10 raised to power 23. Just like dozen, if I say dozen means 12. So this is standard quantity, amount of substance which we measure in mole. These are 7 fundamental quantities. Now after these 7 fundamental quantities, there are 2 more quantities which are known as supplementary quantities. There are 2 more quantities which are known as supplementary quantities. So see, these 7 quantities are like letters of language. In English, you have 26 letters. In physics, you have 7 quantities. All other hundreds of quantities can be expressed in terms of these 7 quantities. In fact, entire syllabus of class 11 can be expressed in terms of just mass, length, and time. That's it. No, Rashad, supplementary are not fundamental. Entire syllabus of class 11 can be expressed just in terms of mass, length, and time. Now, these supplementary quantities are basically those quantities. Shafak, luminous intensity is basically intensity of light. The light intensity that you got from a bulb or any luminous source is luminous intensity. If I take a bulb of 100 watt and if I consider a bulb of 1000 watt, then the intensity of light coming from that 1000 watt bulb is greater than that of 100 watt bulb. That intensity of light is basically luminous intensity that we measure in candela. Yes, Shafat, clear?
Okay, thank you, sir.
Next, see luminous intensity. No, Abdullah, luminous intensity doesn't mean heat. It's not energy. Luminous intensity is just intensity of light. You can relate heat with luminous intensity. You can relate temperature with luminous intensity. But heat, temperature, and luminous intensity are three different ones. Like you can connect temperature and heat, right? Whenever you provide heat to a body, its temperature rise, but heat and temperature are two different quantities in the same way. That heat and luminous intensities are two different quantities, two separate quantities. The next are supplementary quantities. These supplementary quantities are not fundamental physical quantities. Neither we can say that they are derived. They are neither fundamental nor derived. That's why we call them as supplementary quantities. They are not derived. You can't derive these quantities directly from fundamental. You cannot derive these supplementary quantities directly from fundamental quantities. So they are not derived, they are supplementary. They are just two supplementary quantities. The one is angle. We call this as plane angle. We represent plane angle by theta and its SI unit is radian. The angle that you have studied up to class 10, the angle of 30 degree, 40 degree, that's some supplementary quantities that we represented by theta and measure in radian. Degree is not the SI unit. The SI unit of angle is radian. After plane angle, the next is solid angle, which we represent by omega. See, solid angle is basically a three-dimensional angle. It's a three-dimensional angle which is known as solid angle. And we measure solid angle in stereo. Yes, omega. We represent it by omega. And we measure this solid angle in stereo. So these are 7 fundamental and 2 supplementary. Always remember these 7 fundamental quantities as letters of any language. Just like
So is stereo.
yes, steradian. Yes, Rashad.
So is steradian the SI unit of solid angle?
Yeah, it's SI unit of solid angle. Solid angle is basically a 3-dimensional angle. One example of solid angle is that of cone. Cone is a 3-dimensional figure. So this base of the cone subtends a 3-dimensional angle at the vertex. This 3-dimensional angle is basically a solid angle. 3-dimensional angle that we measure in steradian. It's not radian.
सर luminous intensity को कैसे से represent करते हैं?
Luminous intensity को L से.
और L से तो length को भी कर रहे हैं तो confuse नहीं हो जाएंगे?
नहीं, अलग अलग कॉन्टेक्स्ट में आता है. जब luminous intensity आएगा तो लेंथ नहीं आएगा.
और electric current?
Electric current by I or capital. Either I or capital.
Thank you, sir.
सर ये सॉलिड एंगल तो कोन के उसमें हो गया और सब प्लेन एंगल में नॉर्मल ट्रायंगल टाइप रहता है. आई मीन
It's a normal 2-dimensional angle. Normal 2-dimensional angle. This one. और बिल्कुल ट्रायंगल की तरह रहता है. जो एंगल आपने आज तक पढ़े हैं, they are 2-dimensional angle. This solid angle is a 3-dimensional angle. ये कुछ नया है. ये तो प्लेन एंगल वही है जो क्लास 10 तक आप पढ़ते हो.
ओके.
So Fazil, Noor, Fatma, is it clear up to these fundamental and these supplementary quantities?
Yes, sir.
Okay, no doubt. No doubt. Okay. Now I have some doubts. Noor, why we represent this kilogram with a small k, meter with a small m, seconds with a small s, but we represent Kelvin with a capital K, ampere with a capital A, candela with a capital C. Why we consider
So,
it with small letters and other with capital letters? Note.
so because these SI units, Kelvin, Ampere, have been named after scientists, so they're in capital letter.
Okay, okay. Yes, so
सर बिकॉज वो मास में जैसे कैपिटल एम यूज हो चुका है
no,
और टेम्परेचर में कैपिटल के सॉरी टेम्परेचर
no. Quantities which are based on the name of scientist starts with a capital letter. Otherwise, they start with a small letter. Kelvin is the name of a scientist. That's why this is capital A. But meter is not name of anyone. That's why it starts with small a. Ampere is the name of a scientist. That's why it starts with capital A. But seconds is name of, is not name of any scientist. Starts with small a. So units which starts with the name of a scientist that start with a capital A.
So a solid angle is which is made in a 3D figure.
3D figure. In case of spheres, hemisphere, cone, you won't use this three-dimensional angle in class 11. You will use this in class 12 only. There's not a single numerical in class 11 syllabus based on solid angle. So, shall I rub it?
Yes, sir.
यस सर यस सर
Yes, sir.
Okay. Okay, let's rub it up. The next are derived physical quantities. Derived physical quantities. Derived physical quantities. So derived quantities are those quantities which cannot be expressed in terms of, which can be derived from fundamental physical quantities. So derived quantities are quantities that can be expressed in terms of fundamental physical quantities. So quantities that can be expressed in terms of fundamental physical quantities are known as derived quantities. So each and every quantity in physics, else than those 7 fundamental and 2 supplementary. If you leave those 9 quantities, then every quantity is derived. Like energy is derived, velocity is derived, force is derived, magnetic field, resistance, voltage, EMF, these all are derived quantities. So the list is endless. Like force is derived, energy is a derived quantity, resistance is a derived quantity. So all quantities else than those 9 quantities are fundamental. Now after derived quantity, the next topic is, okay, just note it down. I need some space for the next topic.
Done, sir.
Yeah.
सर इलेक्ट्रिक करंट का तो हमारे पास फॉर्मूला भी होता है, तो मतलब वो फंडामेंटल कैसे, इसका मतलब वो कुछ समझ नहीं आया, तो प्लीज एक्सप्लेन कर देते.
Because these quantities are fundamental, it doesn't mean that. So the formula of current is Q by time. You even have formula for length. You can even write your length as velocity multiplied by time.
Yes, sir.
Mass. So mass is force upon its acceleration. This is mass. So these quantities are not fundamental due to any formula. These are fundamental by the way they are measured. The way we measure these quantities will decide whether these quantities are fundamental or not. So when we experimentally measure this mass or current or length, then that measurement will decide.
सर तो और भी क्वांटिटीज को क्यों नहीं मतलब फंडामेंटल रखा, मतलब क्यों नहीं स्टेप से मेजर किया जैसे इन 7 को किया है?
राइट, देखो तुम्हें ऐसा सेट नहीं मिलेगा कहीं, MLTIK इन सबको एक दूसरे से डिराइव नहीं कर सकते किसी भी तरह से। ये सेट इंपॉर्टेंट है। You can't derive mass using any of the fundamental quantity. If instead of current, let's say I remove current और मैं कुछ और use कर दूँ, I say resistance, तो ये possible हो सकता है कि मैं इन सबको combine करके resistance बना दूँ। But ये जो set है इसलिए special है कि you can't derive any of this quantity by combining the other remaining others. That's why they are fundamental. ये set इसलिए fundamental, इसलिए important set.
So what have you written there? L is equal to V into T.
Distance is speed into time.
So what is L?
Length. Length is velocity into time.
Thank you, sir.
The next is dimension. Dimensional formula. Dimensional formula. And dimensional equation. Dimensional formula and dimensional equation. So see, you can express all derived quantities in terms of fundamental physical quantities. When you express derived quantities in terms of fundamental, then you came across these terms like dimension, dimensional formula, and dimensional equation. We came across dimension, dimensional formula, and dimensional equation when we tried these quantities into fundamental. Let's start with a very basic example like area. You can write area as the product of length and breadth. Now, when we say length is fundamental, this is generic. Generic in the sense when you're saying length is fundamental, then every quantity that you measure in meter is length for you. Length is length, even breadth is length for you, even height is length for you, even radius, diameter, thickness, distance, displacement, everything is length. This is generic, like length is length, even breadth is your length. So can I write this as length multiplied by length? Length into length?
Yes, sir.
Yes, sir.
When I say length is fundamental, that means a generic length. Length, breadth, height, all are length. Length into length. So we can just write this as its length square. So area is simply length square. So you can say that area is L square. A is L square. You can even write this area as, see, area does not depends upon mass, it's independent of mass. So I can easily write this as, this is m to the power 0. M to the power 0. L square, it's independent of time, so you can write this as t to the power 0. These are two notations in which you can write dimensions of any.
So what is M? M.
L is length, M is mass, and
Sir,
T,
M.
M mass. M stands for mass. Okay. These brackets that I am using are just a convention. They're just convention. Every author used this notation. That's why I'm writing it. There is no harm if you just remove these brackets. That won't affect physics in any way. These brackets are just notations, nothing else. Just convention.
तो अगर कर्व ब्रैकेट लगा दिया हमने तो कर्व ब्रैकेट
That's fine. मेरे लिए तो कोई प्रॉब्लम नहीं है, बट बुक्स के साथ मैच नहीं करेगा तो मे बी आपके स्कूल टीचर प्रॉब्लम क्रिएट करे. अदरवाइज जस्ट अ कन्वेंशन, आपकी मर्जी है, आप कैसे भी ब्रैकेट लगाओ, ना भी लगाओ, डजेंट मैटर. कुछ बुक्स में नहीं मिलेगा, बट एनसीईआरटी स्क्वायर ब्रैकेट So it's better if you use these square brackets. Now this power of 2, this power of length that we are using, this power 2 is dimension. This power of length that we are using is dimension. This L square, like fundamental quantity raised to its power, this is known as dimensional formula. This is dimensional formula. Similarly, if I write this A equal to L square, then this is an equation. Derived quantity equal to dimensional formula. This is an equation. Is dimensional equation. This is known as dimensional equation. This is dimensional equation. Let's take one more example. Another example. Instead of area, let's start with volume. So the formula of volume is its length into breadth into height. Noor, can I consider breadth and height as just length?
Yes, sir.
Yes, sir.
Yes, sir.
L cube.
Breadth and height can be considered as length. So I can write this as its length multiplied by length multiplied by length. It's length into length into length. So we can just write this as length cube. So V is length cube. Or we can write this as L cube. V is L cube. So Fatima Sharif, what is dimension here? What is dimension of volume?
M raised to 0.
No. Dimension 3. The dimension of volume is 3. What about dimensional formula, Fatima?
L cube.
L cube, right? L cube is dimensional formula. Dimensional formula. And what about dimensional equation?
V is equal to L cube.
V equal to L cube is dimensional equation. Or you can even write this as V is M0 L cube T0. There's another notation, but I will always prefer this one. You're right.
सर हम यूज तो मतलब ये L स्क्वायर और L क्यूब नहीं करेंगे.
हम सिर्फ यही यूज कर लेंगे, इतना ही यूज करेंगे, L स्क्वायर या L क्यूब. ये भी एक पॉसिबिलिटी है जो आप कर सकते हो, बट मैं इसे अवॉइड करूंगा. मैं यही यूज करूंगा, ये वाला. चॉइस है आपकी, आप दोनों में से कुछ भी यूज कर सकते हैं. मैं इसे प्रेफर करता हूँ, L स्क्वायर और L क्यूब. ठीक है?
यस सर.
Okay, just note it down. Abdul will come to every quantity. Abdullah will...
Done, sir.
We will come to every quantity one by one. So, shall I rub it, Janvi?
Yes, sir. No, sir.
Okay. Now, this unit number 1 is the easiest unit of your syllabus. This dimension, error, measurement of length, mass, and time. These are the easiest portion of the syllabus.
And sir, which one is the toughest?
From chapter number 3 onwards. Like 3, 4. The toughest is basically chapter number 7. The 7th includes all. The chapter number 7 includes all chapters from 3 to 6. That's why it seems a bit tough. Otherwise, on difficulty scale, 3, 4, 5, all are almost the same. Abdullah, 7th is rotation. So, shall I rub it? Now,
Yes, sir. Yes.
Yes, sir.
just one more example. Say, let's take with density. When we write density, density is the ratio of mass and volume. We represent density by rho. We represent mass with M1 and we represent volume with LQ. So you can just write this as it's M1 L minus. So the density is simply it's M1 L minus 3. This is the dimension. So rho Abdullah, rho is the representation of density. So here 1 comma minus 3, these are the dimensions of density. So here the dimensions are 1 comma minus 3. Don't just subtract them. We don't subtract dimensions or add dimensions. We write them separately, like 1 comma minus 3 are the dimensions of density. Similarly, if you write this as M1L minus 3, this is dimensional formula. This is dimensional formula. And if you could write this as rho is M1L minus 3, then this is dimensional equation. Just note it down.
Done, sir.
Written. Shall rub it?
Yes, sir.
Okay.
सर
Yes.
सर हम रो तो रेजिस्टिविटी को डिनोट करने के लिए यूज करते थे.
हाँ, रेजिस्टिविटी करंट इलेक्ट्रिसिटी में था, यहाँ डेंसिटी है.
ओके सर.
Okay, let's start. Now, for solving numericals of dimensional analysis, you need to remember dimensions of some quantities. So I'm just making a list of important quantities. You will need dimensions of these quantities to solve numericals of dimensional analysis. So this list will have almost around 20 quantities, but you will need these quantities to solve numericals. Without memorizing dimensions of these quantities, it will be tough to solve numerical. You won't be able to solve numerical without these quantities. So the serial number, physical quantity.
So I wanted to ask that in the previous example, why did you write rho?
Because rho represents density.
Okay, sir.
So quantity formula, dimensional formula. Dimensional formula. SI unit and CG unit. So serial number, physical quantity, the formula of physical quantity. The next is dimensional formula. Then SI unit, and then CGS. SI and then CGS. We will have almost 20 quantities in the list. All 20 quantities are important. The first quantity is distance or displacement. Distance or displacement. Although distance and displacement are different quantities, Distance is a scalar, it doesn't have direction, while displacement have direction. But as far as dimensions are concerned, we consider both distance and displacement as same quantity. So distance and displacement both are length, so we don't need any formula to write dimension. Dimensional formula is L1. The SI unit is meter, CGS unit is centimeter. This is SI and CGS unit of distance or displacement. The second quantity is speed or velocity. Again, there is difference between speed and velocity. Speed is a scalar, it doesn't have direction, but velocity is a vector, it do have direction. But we can consider both speed and velocity as a single quantity for dimensional analysis. Dimensions does not depends upon direction. So the formula of speed is its distance over time, that's speed, and velocity is displacement over time. Velocity is displacement over time. Now, as far as dimensions are concerned, both distance and displacement are length. So when we write dimensions, this is L1 over T1. Distance is length, time is T1. So the combined dimensions are L1 T minus. Again, when we write unit, it's unit of distance divided by unit of time. Distance of unit is meter. Distance of time is second. So the combined unit is meter per second. If you write CGS, so instead of meter, we will use centimeter. Instead of seconds, we will use the SI and CGS unit of time, both are seconds. So that's centimeter per second. Say third quantity. The third is acceleration. We represent velocity by V. We represent acceleration with small a. Acceleration is just the ratio of change in velocity. It's just the ratio of change in velocity over time. Change in velocity by time. Fazil, what should be the dimensions of acceleration? What should be the next step? Fazil.
LL.
The dimensions, just tell me the dimensions of velocity. Velocity and change in velocity will have same dimension, Fazil. So what should be the unit of velocity?
Meter per second.
Unit, dimension formula.
Okay. LT minus 1.
Yeah, dimension formula L1 T minus 1. And what about time?
T.
T. So the combined
LT minus 2.
L. T. What about the unit?
Meter per second square.
Yeah. So the unit is meter per second divided by seconds. So it would be meter per second square. So it's meter per second square. What about the CGS?
Centimeter per second.
Centimeter per second square. Okay, the fourth quantity. After acceleration, the next quantity.
Sir?
Yes,
Sir,
Ariba.
प्लीज एक्सेलरेशन वाला रिपीट कर दीजिए.
Ariba, acceleration is the ratio of change in velocity and time. The change in velocity is represented by delta V. Delta represents change, that means delta V. Time is delta V. When we write dimensions, change in velocity, the dimensional formula is L1 T minus 1. The dimensional formula for time is T1. So the combined is L1 T minus 1 by minus 1. So gets subtracted. So minus 1 is minus 2. Should be like T minus 1 minus 1. When you divide two quantities, then dimensions get subtracted. So L1 T minus. SI unit is meter per second by second. That's meter per second square. And CGS is simply centimeter per second. Yes, Ariba. Clear?
Thank you, sir. Yes, sir.
Now, after acceleration, the next quantity is momentum. The next is momentum. We represent momentum with P. Momentum is simply the product of mass and velocity. Amda, dimensional formula of momentum.
सर मास के लिए केजी.
Dimensional formula, not unit.
सर m m1 और वेलोसिटी के लिए L1 T minus 1.
Velocity is L1 T minus.
T.
Mass is M1. Velocity is L1 T minus 1. So when you combine them, this is M1 L1 T minus 1. This is momentum. And what about the unit?
kg meter per second.
Newton meter. No, sir.
Newton, not Newton. Mass is kg. Velocity is meter per second. So the SI unit is meter per second. CGS?
Gram
Yes.
centimeter per second.
Instead of gram, we use kilogram, we use gram. Instead of meter, we use centimeter. So that is the CGS. Okay, just note it down. Yes, Abdullah. That's your choice, Abdullah. You can represent gram either by G or by G. That's your choice.
Done, sir.
Okay. So shall I rub it?
Yes, sir.
Okay. Noor, Fazil, Fatma, Ariba.
सर मैं लीना हूँ, सॉरी गलती से नाम चेंज नहीं कर पाई.
अच्छा, ठीक है. Okay. So okay, the fifth quantity is force. So Fatima, what's the unit of the formula of force? Fatima Sharif, what is the formula of force? No idea. So the formula of force is mass multiplied by acceleration. Formula for force is mass into acceleration. Okay, Fatima, just try the dimensional formula of this force. Fatima Sharif, try the dimensional formula of force. Yes, Fatima.
M1
Yes, mass is m1, right? And
L1
okay,
T raised to minus 2. T minus 2.
yes, Mass is L1 and acceleration is L1.
L1 T minus 2.
So when we combine them, this is M1, L1,
L1 T minus 2.
minus. What about the SI unit?
Newton.
Detailed unit. It's kg. Acceleration is per second square. So this kg meter per second square could be written as Newton. In one line, you can write this as Newton. So this is the detailed unit, and this whole thing can be written just as Newton. So what about the CGS one? CGS unit.
So gram, centimeter,
Gram,
centimeter, second minus S minus 2.
this we call dyne. Dyne is the CGS unit. After force, the next quantity is pressure. We represent pressure with capital P, and pressure is just the ratio of force and area. So the force is M1, L1, T minus 2 over area, where area is L square. So the combined will be, it's M1, L, when you're dividing L1 by L square, so that's L1 minus 2, T to the power minus 2. So that's M1, L minus 1, T minus 2. So that is the dimensional formula for pressure. It's M1, L minus 1, T minus 2. The SI unit of pressure is force upon area. So it's Newton divided by meter square. So this is Newton per meter square. We can call this as Pascal. If we consider CGs, then instead of Newton, we will use dyne. This is dyne per centimeter square. That's dyne per centimeter square. That's it. After pressure, the next is...
So please repeat it.
Okay. Pressure is the ratio of force and area. Force is M1, L1, T minus 2. This in 0.5. This is force. I use the same dimension here. Divided by area, which is L square. So when you divide force by area, then this is M1. It's L to the power. It's 1 and 2. Just subtract 1 and 2. So it's 1 minus 2. Then this is T to the power minus 2. So this is simply M1, L minus 1, T to the power minus 2. So that's pressure. M1, L1, L minus 1, T minus 2. Clear up to this point?
Yes, sir.
Yes.
डाइन का कोई सिंबल नहीं है, फिर ऑलरेडी ये ऐसे ही लिखते हैं, सब सिंबल है ये.
कोई symbol नहीं है ऐसे.
ओके सर.
Now, if we consider unit, then this is force is Newton, area is meter square. So that's Newton by meter square. So it's Newton per meter square. And this Newton per meter square could be written as Pascal. When you take CGS, instead of Newton, we consider dyne. Instead of per meter square, we write per centimeter square. The next code is work done. The next is work done. Work done is simply the product of force and displacement. Janvi, what should be the unit of work done? Dimensional formula. Janvi.
So M1 L2 T to the power minus 2.
M1, okay, good. So force is just M1, L1 T minus 2. Here displacement is L1. Combined is M1, L square, T minus 2. So this is the combined unit of work done. Work done is force multiplied by displacement. Force is simply M1, L1, T minus 2 multiplied by displacement, which is L1. So the combined is M1, L square, T minus 2. So the SI unit, if we consider unit, so detailed unit of force is kg. I'm just writing these detailed units because you will need these units in some numericals of NCERT. Even for solving NCERT, you will need detailed unit of force. You may need detailed unit of this work done. That's why I'm writing these detailed units. So detailed unit of force is force is this kg meter per second square. So the detailed unit of force is kg meter per second square. Multiplied by that of displacement, displacement is meter. So the combined is kg meter square per second square. And in one line, we call this as joule. So this is joule, kg meter square per second square. Similarly, you can write CGS unit. Instead of kg, you can use gram. Meter square, you can use centimeter square per second square. Or instead of joule, we will use erg. So CGS unit of energy is erg, not joule. Any doubt in these three quantities, force, pressure, and work done? Any doubt in these three quantities, force, pressure, work done, in dimensions or in units?
Sir, are we gonna use the dimensional formula in the book ahead or only in this chapter?
We will use dimensional formula only in this chapter. But
Okay, so we have to learn them.
Yes, you have to remember.
So what is the SI unit of work done there? Kg meter square.
Per second square. Kg meter square per second square. It's 2.
सर आपने CGS में लास्ट में ब्रैकेट में क्या लिखा है?
Erg. ERG. Erg.
ओके सर, थैंक यू.
ERG. Yes, Abdullah. Right. Okay. So, shall I rub it?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, after this work done, the next quantity is power. This would be 10th, na? 10th quantity.
So
8.
8. This is 8th quantity. So the 8th quantity here is power. The formula of power is its work done over time. This is the formula of power. Calculate its dimensions and report your answer in chat room. Just calculate the dimensions of power and report your answer in chat room. Calculate dimensional formula of power. It's simply work done over time. Rehab, right. Sania, okay. Sania is correct. Janvi correct. Fazil is correct. Noor correct. Abdullah Aslam, yes, correct. So almost all are doing right. What about the rest? Yes, Mubashira, Fatma, it's correct. Shafaq, it's correct, right? Yes, it's work done over time. So the work done is simply m1 L squared T minus 2, right? Over time. T1. So this is simply M1 L square T minus 3. So if we divide T to the power minus 2 by T1, that comes out to be T to the power minus 3. So here the SI unit is work done is joule, time in second. So that is joule per second. Yes, joule per second could be written as watt. Yes, Sania, watt is correct. Next, you can write CGS unit as erg. CGS unit of work done is erg divided by time. So that's erg per second. Instead of joule, you can use erg. That is erg second. That is the CGS unit. Now, after power, just remember this sentence that work done, and all types of energies, have same dimensions. So work done and all types of energies have exactly same dimensions. So the dimensions of kinetic energy, potential energy, heat energy, sound energy is same as that of work done. Not just kinetic energy, Abdullah. Even potential energy, heat energy, light energy. The dimensional formula of each energy is same as that of work. That is M1 L square T minus. So all types of energies have same dimensions as that of work. Now after power, okay, first solve some numericals based on these 8 quantities. Then we will come back to this list. Let's do some numericals which are based on these 8 quantities, and we'll come back to this. So, shall I rub it up to the dimensions?
Yes, sir.
Yes, sir.
Yes,
It's
sir.
a
Yes, sir.
So, I'm rubbing it. So, the first question of the series. So, in the very first question, you will realize why you need that list. So, the first question is, this expression is given. F is G M1 M2 over R square. Here F is force, M1 and M2 are masses, R is the separation between masses, calculate dimensions of G. Calculate dimensions of G. You need dimensions of universal gravitation force. So this G here could be written as G is Fr square over M1 M2. So G is Fr square divided by M1 M2. Just cross multiply this R1, R2 and M1 M2. And now just start writing dimensions of every quantity. The dimensions of force is M1 L1 T minus 2. The dimension of this R length is L1, so this is length square. M1 and M2 both are masses, the dimensions of M1 is M1 and M2 is again M2. So G is, it's M1, L1, T minus 2 multiplied by L square divided by M square. So the G is, it's M1 by M square. So this is M to the power 1 minus 2. It's L1 into L square. So that's L to the power 1 plus 2. Then this is T to the power minus.
So what do you mean by R?
R is length separation. Separation between two masses, which is length. R is length basically. So the unit of dimension formula of G is M minus 1 L cube T minus. So this is the dimensional formula for universal gravitational constant. It's m minus 1, it's L cube T minus. So is this example clear? Because next numerical is based on this one.
Yes, sir.
Yes, sir.
Yes, sir.
No doubt.
Yes, sir.
Okay. Then solve this numerical. If you don't have in this doubt in this numerical, then solve this one. Force is eta A here F is force, A is area, dV is change in velocity, dV is change in velocity, dx is change in position. Position is length. Dx is change in position. Change in position is basically length. Calculate dimensions of coefficient of viscosity, eta. Okay, solve this numerical. Report your answer in chat room.
सर एफ के बाद आपने क्या लिखा है?
Eta. This symbol is known as eta. It's eta. The name of this symbol is eta. The Greek symbol eta. F is force, A area, dV change in velocity, dx change in position. I need dimensions of this eta, coefficient of viscosity. Solve it. Okay, Rehab. Just a second, let me calculate first. So it's F. Yes, Rehab Khan got the right answer. Noor is correct. Abdullah Aslam is wrong. Abdullah, just check your calculations once more. And what about the rest? The three answers. Sania Fatma is correct. Fazil is correct. Alina is correct. Rashad is correct. Now, Abdullah, you are correct. Fatma, Janvi, Hamda.
सर एक मिनट.
Na. Shafaq. Yes, Fatima, correct. M1 is minus 1, T minus 1. Swalia, Hamda. Hamda, it won't be T to the power minus 3. It would be T to the power minus 2. Minus 1. Just check your calculations. You're making mistakes in subtraction.
Yes, sir. आ गया समझ में.
So see, you can write eta as eta is f over a dx over dv. So eta
So
is,
मैंने लिख दिया.
okay. Yes, Janvi, it's right. It's correct. So it's m1 L minus 1 t minus 1. Sorry. m1 L1 t minus 2. dx is length, which is L1. A is area, which is L square. dv is velocity, which is L1 t minus. So here this L1 will cancel this L1. This L1 will simply cancel this L1. And we are left with its M1. It's L to the power 1 by L square. So that's L to the power 1 minus 2. It's 2 to t to the power minus 2 plus 1. So the coefficient of viscosity is its M1 L minus 1 t minus. So this is coefficient of viscosity M1 L minus 1 t minus. So almost all were correct. If you have written up to this numerical, I should rub it. Okay.
Done, sir.
For other numericals, we need the same unit. We need dimension formula of some more quantities. So the list was up to last quantity was 8th or 9th?
So 8.
8th.
9th quantity. The 9th is angular displacement. Ninth is angular displacement. So the angular displacement is just an angle. It's an angle. And the definition of angle is length of arc divided by the radius of arc. This is the definition of angle. It's length of arc divided by radius of arc. So angular displacement is just an angle. Say you have this arc. This is the center of arc. The length of this arc is L. The radius of this arc is R. And this is angle theta. So the definition of angle is simply the length of arc divided by the radius.
L upon R.
L upon R. Next, when we write dimensional formula, then length of arc is length. Radius is again length. So it's length over length. So they gets cancelled out simply L0. So you can say that your angle is dimensionless. So angle is dimensionless. It doesn't have any dimensions. The next is the SI unit of angle, which is radian. The SI unit is radian. There is no CGS unit of angle, so I'm not writing CGS unit here. There is no CGS unit of angle, so I'm not writing any CGS here. The next is 10th quantity. The next is angular velocity. The next is angular velocity. We represent angular velocity by omega. Angular velocity is just the ratio of angular displacement. It's just the ratio of angular displacement and time. See, angular displacement is dimensionless, so that's L0. The dimensions of time is T1. So the combined is L0 T minus. If we write unit, Fazil, what should be the unit of this angular velocity? Fazil, SI unit.
Radian per second.
Angle radian. Time is seconds. So the combined will be radian per second. No C.
So,
yes.
So can't the dimension be simply t minus 1?
Yeah, dimension would be simply T minus 1. L0 T minus 1 or just simply T minus 1. Unit is radian per second. There is no CGS unit of angle. There is no CGS unit of angular space or angular velocity. After angular velocity, there are few more quantities like angular acceleration, torque, moment of inertia. I will send you a PDF document, a very detailed list of few quantities. I just can't write dimensions of each and every quantity. Otherwise, this is a very lengthy, but it will take 4 to 5 hours just to write dimensions. My aim is just to write the minimum number of dimensions, minimum number of important dimensions. So these 10, 12 quantities are important for writing dimensions. After angular velocity, the next is strain. When we write strain is the ratio of change in configuration, divided by original configuration. The ratio of change in configuration and original configuration is known as strain. When we write configuration, it could be anything. It could be length, it could be area, it could be volume. So this is just length by length. Can you guess the dimensions of this quantity if it is length by length?
Sir, 0.
0.
L0.
Dimensionless, matlab.
Dimensionless.
Dimension, yes. So strain is a dimensionless quantity, remember? It's even unitless. There is no unit of strain. And just one more thing. In dimensional analysis, our entire motive is just to write these dimensions. The other details of quantity was what these quantities physically explain, how we came across these formulas. We will do this in the entire syllabus. On each and every quantity, you have one chapter. You have one chapter on strain, you have one chapter on angular velocity. So in dimensions, our motive is just to write the dimension formula, that's it. All other details will come in the coming chapters. So at least at this stage, just don't worry about what is angular velocity, how you derive this formula. You just need to write this dimension formula only and units. That's it. That's the entire motive of dimensional analysis.
So,
Yes,
so is strains same as tension?
no. Tension is a force, the type of force. Strain is not. It's force basically. Just note it down and then we'll rub it.
Done, sir.
Yes, Abdullah. Tension and weight are forces, they will have same dimensions. Okay, let's rub it. The next quantity is quantity number 12. Serial number. Quantity.
So we are gonna do all 20.
No, not all 20. But at least all important quantities. Physical quantity, formula, dimensional formula, SI unit, and series. Okay, the next is, after strain, the next is heat. Heat is easy. Heat is a type of energy. So what is the unit of dimension formula of energy? I've written in a statement earlier.
Similar to that of work.
Similar to that of work. The dimensional formula of energy is m1 L squared T minus 2. SI unit of is joule. CGS unit of heat energy is calorie. Its CGS unit is calorie. All other types of energies, the CGS unit is Earth, but particularly for heat energy, the CGS unit is Kelvin. After heat energy, the next is temperature. See, temperature is a fundamental quantity. It's fundamental. You don't need formula for temperature. The dimensional formula is simply θ1 or it's simply K1. This is the dimensional formula of temperature, θ1 or K1. If you write unit, then the SI unit is Kelvin and the CGS unit of temperature is Celsius. After temperature, the next quantity is like specific heat. We represent specific heat with capital small s. The formula is delta. We represent heat with delta Q. We usually represent heat with capital delta Q. So delta Q is ms delta T. So delta Q is heat. This m is mass. This delta T is temperature. From this expression, we can write S as delta Q over m delta T. Write down its dimensional formula, its SI unit and its CGS unit.
So what is S in this formula?
S is specific heat. S is specific heat.
So no, not this sir. So Q is equal to ms. So is it mass or m is different? S is different.
S is specific heat. M is mass, S is specific heat.
Okay. Okay.
So Rehab, which one?
तो आपने कहा केल्विन और कैलोरीज कुछ बता रहे थे ना?
The SI unit of all energies is Joule, including heat energy. But the CGS unit of all energies is erg except heat energy, which is calorie. So except heat energy, CGS unit of every type of energy is erg. Only the CGS unit of heat energy is calorie.
Okay, sir. Thank you, sir.
Just calculate the dimensional formula of specific heat and report your answer in chat room. Specific heat, dimensional formula of specific heat. So Abdullah got L squared T minus 2 K minus 1. Okay. Yes, Abdullah is correct. Alina is correct. Noor is correct. Yes, Sania, you are correct. Sania Fatma. Rashad, you are missing temperature. Here, delta T is temperature, not time. Yes, Fatima, you are correct. Fatima Sharif, you are correct. This is pretty straightforward. Huh? So S is, yes, Fazil, you are correct. Delta Q over M delta T. So delta Q is M1 L squared T minus 2. M is mass, which is M1. Delta T is temperature, which is Kelvin. So the combined is, it's M0 L square T minus 2 K minus 1. Now you can just leave this M. You can just write this as L square.
Sir, what is that delta theta?
Delta theta is heat. It's delta Q basically. That is for heat. We represent delta Q. Now, if we write units, Then the unit is it's delta Q by m delta T. Delta Q SI unit of delta Q is Joule divided by mass, which is kg. Delta T is temperature, which is Kelvin. So the combined unit is Joule per kg per calorie. If we write CGS unit, then instead of Joule, you can use erg. Instead of kg, we can write gram. Instead of Kelvin, we can write Celsius. So it's erg per gram per degree Celsius. That is the CGS. Oh, sorry, not erg. It will be calorie. It's heat now. CGS is calorie per gram per degree Celsius.
तो CGS यूनिट क्या लिखा आपने?
Calorie per gram per degree Celsius.
Sir, what you have written in the CGI?
CGS. It's calorie per gram per degree Celsius. It's calorie per gram per degree Celsius. I'm just leaving, Rashad. Leaving in 2 minutes. It's calorie per gram per degree Celsius.
Sir, what's your name?
Azam.
Okay, sir.
So I've written.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Let's stop here. The next class is on Saturday. Next Saturday at the same time. I will try to manage one more class in weekdays, maybe on Wednesday and Tuesday. I will inform you the timings accordingly. But officially, the next class is on Saturday and Sunday only. The timings are the same time. If I could keep a class
Sir, on Saturday we have class test of school.
at what time?
3.
At what time?
Sir, this time only.
This time only. Okay, we'll try to manage the timings for you.
सैटरडे संडे दोनों है ना? I mean दोनों दिन.
दोनों दिन. दोनों. Okay, let's stop here. We'll continue next week on Saturday.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Allah Hafiz, sir.